Hello, I'm Albert Liu, founder and CEO of Kneron, a full-stack AI company. And today, I'm here to announce our next generation chip, AGI, the KL730. However, first thing first, let's take a step back and take a look at the global context into which the KL730 is being born. AI is being deployed everywhere. Powerful AI software such as GPT, LLMs are advancing way faster than anyone, including experts previously saw possible. This brings about a lot of excitement as well as uncertainty. Regardless of either, the trajectory is clear. AI will keep advancing and become the increasing integrated part of our life. Now, Kneron is an AI chip and software company. We too are working to accelerate the deployment of AI. Starting out in 2015, we are a handful of electric engineers and scientific dreamers sitting in the corner of Qualcomm San Diego headquarters who, even before anyone else took AI seriously, imagined all sorts of cool things AI could do for the world. Driven by this vision, we pick ourselves up and move across the street from Qualcomm, where we began to experiment recipe for a semiconductor chip smaller than the size of a coin that could feed the largest, most powerful AI software possible. And thus, today, we find ourselves at the epicenter of AI wave that, when suitable applied, could very well enable the full human potential. Nonetheless, there are a number of hurdles to get past. First off, massive energy consumption is required of current mainstream computing hardware to run powerful AI models. Secondly, cloud computing is today the predominant method for deploying AI. Edge devices from various corners of the world send data to the cloud centers where the AI lives on centralized computing hardware operating by tech giants. This practice is inevitably associated with privacy and security issues. And finally, as AI revolutionizes productivity and creates new opportunity, it remains a crucial task to ensure the society at large manages to catch up and benefit from those wondrous new technology. Now, we at Kneron have been charming out NPU chips and tuning AI model for 8 years, way before anyone else. Watching competitors come and goes, we would like to think we know the things or two about AI. So here are our 2 cents on those questions as well as our solution to them. First of all, about energy consumption. Remember Moai statue. Those wondrous statues are really cool, but they are likely also the reason for which today there's remain no people living in Eastern Island. The environment burden of building those mobile statues was simply too immense, straining the island's resource. At Kneron, we believe that AI should help humans transcend and realize our creative potential, but not at the cost of mismanaging the environment in which we inhabit. Between the year 2012 and 2018, the amount of computing power required of record-breaking artificial intelligence models doubled every 3.4 months. Recently, this doubling time has shortened to every 2 months. One of the largest models released in 2020 used 600,000 times more computing power than the noteworthy 2012 AlexNet model, which kicked off the population of deep learning. In this meantime, there has not been enough adoption of efficient hardware to sustain this mass compute need on both the end of training and inferencing. Today, as a result, to scale the adoption of ChatGPT to hundreds of millions of users, it will cost more than a whopping $5 billion a year to run the model of applications, or take the training of Google's Rich Transformer, for instance, that consume 179 megawatts and produce 59 metric tons of carbon dioxide emissions. The main reason behind those runaway costs is the sheer amount of energy that AI consumes at the cloud hardware centers. This said that it's crucial to consider the type of hardware on which these AI models are running. This hardware needs to be ultra energy efficient. They need to be dedicated in running AI. They need to be designed from the start with AI in mind. Here's a cautionary tale to consider if we look back in time at the all-star of rising graphic compute needs. Intel used to insist that graphic-dedicated GPU are superfluous because CPUs are enough to run graphics. Now we can see how that could not have been any further from the truth. Likewise, running AI requires Thin-9, optimized AI dedicated chip with an architecture design that is completely different from anything else we have seen before. A simple reappropriation of adjacent technology such as graphic-dedicated GPU chip simply is not doing the job. Over the past years, our technology and business impact has gained quite some recognition from both the academic and business world. The paper of our core reconfigurable architectures was featured on Nature Electronics. As of this year, it has also been awarded the IEEE Darlington Award, which is the highest honor in electric engineering, and it garners very first report on Edge AI. We were featured as one of the key providers. And today, we continue our lead in rising the bars of cutting-edge, efficient AI computing hardware, introducing the KL730. The KL730 is an auto-grade NPU chip with integrated ISP feature, a peripheral interface that connects image, video, audio, mini-wave, and other digital signal all in one, enabling a wide range of AI applications from smart home appliance and security system to advanced driving assistance system, intelligent vehicle cockpit, and enterprise edge server with a low energy footprint. Compared to our previous chip, the KL730 yields a 3 to 4 times leaps in compute energy efficiency. Compared to other peers by major competitors, the KL730 is also 150 to 200% more energy efficient. Now we have cleared that the questions of energy efficiency. Let's go on to talk about privacy and security. On any given day, we prefer Wall-E and Doraemon, Rubber Cat over Skynet and Matrix. Small, decentralized AI is always better than big, centralized AI for managing both personal and enterprise data privacy as well as security. Over the years, Kneron has brought about a series of lightweight but scalable chips that are capable of hosting AI models across the full spectrum of edge applications without cloud connectivity. With the addition of KL730, we now have a range of stackable chips ranging from 0.5 to 3.6 efficient tera operations per second, which can be cascaded together in various combinations to meet the precise computing power specification of range of devices. For instance, stacking together 2 to 4 KL720s enable drones. Stacking together the KL520 and KL630 enable a small vehicle, DMS mirror. And this cascading is done without any loss in compute efficiency. In 2021, we launched the KL530, the very first edge AI chip on the market to support transformer neural network, which is the basic of all GPT models. Short of generative pre-trained transformer models, and as of today, we launched the KL730, which poses the most advanced lightweight GPT, large language models such as Narrow GPTs. And most importantly, on the KL730, users can choose to run these models either partially or completely offline, doing something like this.
Hey Neo,
Yes,
what type of rock is in this image?
the image shows a waterfall in a rocky landscape. The waterfall is surrounded by tall, vertical cliffs made of volcanic rock. The waterfall appears to be in a natural setting with greenery glowing on the rocks surrounding it. The waterfall is likely located in a volcanic area where lava has flowed and cooled, creating the following cliffs and waterfall.
Hey Neo,
Yes,
what is the name of this mountain?
the image shows the Kirkjufell mountain in Iceland. Kneron is a mountain in the north of Iceland, and it is known for its stunning views and beautiful sunsets.
Edge AI is going to connect textbook knowledge to the real world. Now I'm an engineer. If my daughter saw such a rock formation that asks the same question, I won't be able to answer that unless I happen to have a geography degree with intensive field work training. But today, knowledge that has for years been locked away in university can now be accessible to anyone on the spot, out in the field. Imagine driving on the road anywhere in this world. Your intelligent copying system serves as a new lens into the physical and cultural world around you, giving you insight and in-depth experience that were otherwise inaccessible. Where Edge AI could do something like this. Helping you become infinitely more productive and creative, designing a new semiconductor chip without having to feed all of your confidential data and sparks of genius into the hands of big cloud companies that operate data centers. The AI doesn't have to live there. It could live on your own edge device. Edge AI solution, as exemplified by the KL730, give private and secure access to insights and productivity that enable humans to experience and create like never before. In one sentence, answering to the challenge of energy consumption as well as privacy and security issue, Kneron launched the KL730 with the state-of-art performance. So, what's the secret sauce behind the chip? And what full range of possibility does that offer? The KL730 is designed uniquely to support transformer neural network, which, as I mentioned, is the basis of all GPT models or generative pre-trained transformer models. All neural network transformers are particularly well suited for both natural language processing (NLP) and image processing tasks. Transformers are able to learn long range of dependency in text and image, which makes them better at understanding the meaning of sentence and paragraph, as well as the relation between the pixel. They have been shown to achieve cutting-edge results on the variety of NLP and automotive tasks. True examples such as ChatGPT as well as demonstration you have just seen that will already understand the power of transformer in language processing. However, that's not at all. Transformers are also the window to next-level image processing or numerous mission-critical tasks. To contextualize those advances, let's first take a look at traditional CNN models, which have been widely used for various image processing tasks. Those models are capable of identifying specific object or feature in the image. They identify the location and boundary of object in an image, or they classify an image into a specific category. On the other hand, transformer-based AI models are capable of understanding the global content of an image, on top of performing semantic segmentation, wherein the model identifies all of the objects in the image. Those models are also capable of seeing, of understanding, wherein they make sense of overall layout of an image. This becomes extremely helpful for mission-critical use cases such as understanding traffic signal and sight, road marking and behavior of surrounding pedestrians and vehicles, road planning, and real-time decision-making. The inception of a new class of Edge AI chip built to run transformer neural network, pioneered by Kneron's KL530 and KL730, is testimony to our mission to make life safer and smarter by categorizing decentralized, cooperative AI technology everywhere. On or off the cloud, we want AI to work for everyone. We achieve this through the minimalizations of highly efficient computing hardware, where computers once fill the space in entire room. We are now capable of running powerful AI models on a few chips, size smaller than a dime. Chipsets are the bottleneck to advanced AI applications, as well as the constraint as to how easily, securely, and decentralized we can deploy them. Ranging from AIoT, security, automotive, to edge server application, we now support more than 30 customers who ship product with Kneron chip inside. In automotive, through our partner, we have deployed our solution with several renowned Japanese car makers. In edge server, we design in with the world's leading server provider, Quanta and Naver and Zhonghua Telecom, replacing the NVIDIA solution and cutting infrastructure's costs by 75% for the customers. In security device, we serve more than 20 IP camera models with Hanwha, one of the world's largest global IP camera provider. In AIoT, we also have the provider to Panasonic, Desmond, the long-standing global leader in AIoT. But I digress. Now let's get to answering the final questions surrounding AI. How do we ensure that society at large stands to benefit rather than lose out from powerful new technology? Surely many social structures must rise to this transition, and on the basic level, AI literacy need to become widely accessible. Currently, key AI knowledge as well as hand-on experience exists mostly within the confines of university and capital-rich tech companies. However, we need more people to join the process of defining AI. To this end, over the past 3 years, Kneron has worked to push forth a series of programs, texts, as well as technical solutions that promote AI literacy on every levels, from K to 12 and higher education to continuing study for professional and small business operators. Shout out to this TSMC Education and Culture Foundation, which sponsored an introductory program for elementary school in Euro-Taiwan based on materials provided by Kneron. No less important that being the active support of Li Kai-chen's foundation, sponsoring both research as well as program offering with the Education University of Hong Kong, backed by technical and material support from Kneron. The initiative trained more than 250 undergrads who are on the track to become school teachers in fields ranging from language education to science education, helping them to employ AI tools in the classroom. Other partners have joined forces to host summer camps and hackathons for K-12 students and online programs for adults to learn about AI. Enabled by Kneron's hardware tool and Neo open platform of pre-trained models, students create and upload applications that resolve real-world problems from cardiac anomaly detection and child safety to automate a trash sorting system. We also want to acknowledge the professor who experiments with Kneron's deep learning hardware expertise at institutions around the world, including University of Virginia, UCLA, and Israel Institute of Technology. And finally, the publishing house IEEE Wiley, Cups, and Zhonghua Book Company, which eventually make those classroom materials available to the public. Moving forward, Kneron continues to make our AI knowledge available to more diverse learners, not just to inform, but mobilize wider set of communities in tracking difficult questions on every front. The future is now. Let's work together to propel GPT at a scale for the best of the human potential, sustainable, secure, and infinitely creative. Thanks for watching.